what we were able to show is that it's not so much how much NMN you take, but it's more what the reaction of the body is to predict if you have a clinically meaningful outcome parameter being positive, so that you're walking faster and you have a better quality of perceived life. And there we showcase that it is important that you are taking so much NMN based on what you need, changing your NAD levels by 20 nanomole per liter. And that is the first study which is mimicking a little bit how we would normally conventionally do it in clinical practice. We would, for example, taking the example of diabetes. Somebody has diabetes. What would you do? You would measure the glucose level. You would give insulin or you would give a drug. And what you would do again, you would measure the glucose level. And you are titrating your drug based on a glucose level. So here, for the first time, we now think to have a cutoff point, so an increase in NAD levels by 20 nanomole per liter. And now further studies we are doing is titrating the NMN based on the NAD levels. And I think that's the way how we should do, because you are reacting differently compared to me. There was lots of heterogeneities in the group, so people are reacting differently to the supplementation, and the needs of how much somebody should take is very different.
Hello, Dr. Maier. You are a professor in the Center of Healthy Longevity at the National University of Singapore. So welcome to Modern Healthspan, and thank you so much for joining us today.
Thank you for having me.
So, Dr. Maier, maybe just to start with, could you tell us a little bit about your history and why you've gone to Singapore?
So I am an internal medicine specialist. I grew up in a GP practice, surrounded by patients. It was a long journey until stating, yes, I will become a physician, but in the end, I became an internal medicine specialist and geriatrician. During that path towards becoming a physician, I always did research. And at a certain time, while moving from one country to the other to not only do research, but also especially hospital management, there was an opportunity to come to Singapore. In Singapore, there are two challenges, I would say. The fertility rate is very low. The health span is not as high as expected. So I'm really here to see how we can prolong the healthier, optimal lifespan.
Excellent. It would be good to talk about that in a bit more detail, because I think Singapore is thinking about this more than most places, because those two issues are common in many advanced societies, that they have low birth rate and not very good health span. So are you an MD and a PhD? Is that correct?
Yes, that's absolutely correct. So MD and then specialization in internal medicine and geriatrics. And I did my PhD culturing fibroblasts to actually see how long cells we are extracting out of our body, how long they can live, and if that might be determining our lifespan.
Interesting. So in Singapore, you're looking at some interventions using nutraceuticals. I think repurposed drugs is one of them, but also nutraceuticals that may help with aging. But you're trying to gather more concrete data on that. And there were a couple that I would like to kind of talk about. And so one of these is AKG. I think you're running a trial on AKG. Could you talk a little bit about how that trial is set up and what endpoints are you looking for?
Yeah, so AKG is alpha ketoglutarate. It's a wonderful molecule. Really trying to have a positive effect of that molecule on many outcomes, also on cellular basis. It has been shown that it might modify our epigenetics. So the epigenetics is the structure of the DNA is quite constant. So that's what our genes are. And then what we can modify it based on epigenetics, what kind of methylation sites there are. So AKG is likely playing a role there, but also how our mitochondria are functioning, so really getting energy into our cells. So AKG, alpha-ketoglutarate, is one of the wonderful molecules we are studying at this moment in time in healthy individuals being aged 40 to 60 years. And we are including individuals which are biologically older compared to the chronological age. So what does it mean? You have a group of 40 to 60-year-olds chronologically, but some of them are biologically older, which means that the pace of aging they have might be higher compared to other peers. So we are only including the ones who are biologically older compared to the chronological age. We are giving AKG to then see if the biological age changed. And how do we measure biological age? Using epigenetic markers. So again, your DNA is fixed. And then based on the epigenome, where sites are to either regulate DNA positively to say, okay, I want to use this gene, or not using the gene. We are looking at these kind of patterns. And now we have clocks. For example, the ones who have been originating from Steve forward, and we are using them to determine the biological age, and that's our primary outcome. Next to the biology, so we are taking cells of individuals, we are taking blood, we are looking at the entire body to see how that aging process is progressing during this 6 months of intervention, and see if we really made a body younger, and if we can do that.
Right. So you'll be looking at the phenotype as well as but yeah, I guess the body markers as well. So 6 months, when do you expect to see the results from that?
Oh, very, very, very soon. So we are, 90% of our trial clients already finished the study, and now we are waiting for the last to be released out of the study. And the study is 9 months, so 6 months of intervention and then 3 months of follow-up. Because very often we forget to actually see if we are stopping a supplement, what that might do for the body. So there's the 3 months period of washout.
Right. Will it go through peer review, or will you put it on preprint? Or yeah, because peer review can take an indefinite amount of time.
Yeah, all our studies will go through peer review in international journals. We have to wait first, of course, to see what the analysis really show, and then it will go through peer review. It depends on how you prepare that. So we already have publications out of our ABLE study. So that's the study with alpha-ketoglutarate. So while waiting until the last patient or client participant is out of the study, we already start publishing the results. So at the moment, we are preparing a manuscript answering the question, is it possible to recruit individuals being all healthy who want to become healthier? That's the reason why they are participating in that study. But really detecting the ones who are biologically older, and is that feasible? And what we actually show is, yes, it's absolutely feasible. 50% of the population we are seeing, they're also biologically older, and they would love to participate in these kind of studies. So don't worry, we are preparing the manuscript, so we will release the data as soon as possible once we have them in.
Excellent, thank you. Just dose and what form of AKG is it?
It's calcium AKG, so there are different forms of that molecule. There are also products on the market who then mix it with even vitamins and other supplements in there, but it's calcium AKG. There's lots of debate what is better. I don't think that we can answer that question at this moment in time, because you would love to see head-to-head trials, not only in vitro, so in the lab, but especially in humans. But this is an unanswered question. For me, it's very important first to see a signal. And once we have the signal, we can optimize the products we are working with. And there was giving guidance to individuals who would love to take it.
Right. Sorry, and dose is?
The dose is a gram.
A gram, great. Yeah. So your team looked at a paper, a human trial done by NMN, and you did a post hoc analysis to see whether the signal was stronger based on the NAD changes in the blood. If you recall that, because I remember I read the paper, and I must admit the statistics were a bit difficult for me. The way, but could you kind of say, what did you see in that? Because one of the things with NMN is, in mice models, it seems to do very well, but in human trials, it has had less consistent results. So what did you see in that in terms of how the improvements happen within, if you looked at it with respect to NAD changes in the blood levels?
Yeah. So let's start with the original study I was also involved with. So that's a four-arm randomized controlled trial. So what does it mean? We have 4 groups. We have one placebo group, and then we have 3 active groups with different dosages of NMN supplies, 300, 600, and 900 milligram. What we were able to show there is that there was a dose-related effect on NAD increase, which is, of course, this is what NMN should do, should increase NAD. So the NAD change was the primary outcome. And we were able to show that individuals who took 300 milligram had a little bit of increase in NAD levels, and then 600 had a much, much more increase. And then compared to 900 and 600, there was not much more increase, which means at a certain time there's a plateau. And I think that's very important. We need many more studies showcasing us what kind of dosage we should, or people should use. Next to the increase in NAD levels, we also looked at factors like gait speed. So how fast is somebody moving from A to B, and the ability. We also looked at quality of life and many more laboratory markers. What we were able to show is looking at clinical outcome parameters, for example, a gait speed or quality of life, that individuals who took 600 and 900 milligram, they had a much, much better effect compared to the ones who either took the placebo or the 300, which means that there is a dose relationship, not only with the increase in NAD levels in the change, but also likely, and the disclaimer is it was a small study, with clinically meaningful outcome parameters. So we ask ourselves, okay, if there is a dose relationship, we are seeing a huge variation between individuals, even within the groups, taking 600 and 900 and 300, but even seeing a huge variation in the placebo group, who is actually responding and who is not responding. And that's the paper you are referring to. Mm-hmm. What we were able to show is that it's not so much how much NMN you take, but it's more what the reaction of the body is to predict if you have a clinically meaningful outcome parameter being positive, so that you're walking faster and you have a better quality of perceived life. And there we showcase that it is important that you are taking so much NMN based on what you need, changing your NAD levels by 20 nanomole per liter. And that is the first study which is mimicking a little bit how we would normally conventionally do it in clinical practice. We would, for example, taking the example of diabetes. Somebody has diabetes. What would you do? You would measure the glucose level. You would give insulin, or you would give a drug. And what you would do again, you would measure the glucose level. And you are titrating your drug based on a glucose level. So here, for the first time, we now think to have a cutoff point, so an increase in NAD levels by 20 nanomole per liter. And now further studies we are doing is titrating the NMN based on the NAD levels. And I think that's the way how we should do, because you are reacting differently compared to me. There was lots of heterogeneities in the group, so people are reacting differently to the supplementation, and the needs of how much somebody should take is very different. So first of all, there needs an indication that somebody, a participant or in clinical practice already, needs NMN. The second thing is how much, for, in a non-answered question, for how long.
Right. Are you doing any NMN trials at the moment? You're in Singapore?
Yes, so we are actively within the ethics phase at the moment to not only showcase and hopefully soon have the answer, how do we measure NED? Because we need to know if there are consumer products out there to measure NED, so how to titrate. And the second thing is we are going to titrate the NAD levels and then give different amounts of NMN to individuals to reach that point of 20 nanomole per liter.
Are you getting enough magnesium? Magnesium in the soil has been drastically reduced since the 1950s and is also removed by food processing, which explains why it's estimated that up to 75% of the population may be deficient. And if you've recently engaged in any sort of restricted diet for weight loss, there is a higher chance that you're not getting enough magnesium. Magnesium is a crucial mineral that's involved in over 600 biological reactions and offers amazing benefits for sleep, stress management, and hormone balance, all key factors for keeping your weight on healthy levels. Don't let magnesium deficiency derail your goals. Try Magnesium Breakthrough today and give your body the support it needs. Unlike other supplements, Magnesium Breakthrough by BiOptimizers contains all 7 forms of magnesium that your body can actually absorb, ensuring you get the full spectrum of benefits. For an exclusive offer, go to bioptimizers.com/modern and use the promo code MODERN10 during checkout to save 10%. And if you subscribe, not only will you get amazing discounts and free gifts, you will make sure your monthly supply is guaranteed. Thank you for your support. Okay, if we took a step back and we were to think about aging in general, because I think potentially the current way that aging is looked at is not optimal. But one of the key things we need to think about is we want to extend Healthspan, right? Extending Healthspan is, it's the name of our channel, and that's kind of the whole purpose. How would you define Healthspan? Is it something that we can measure, and how could we do that?
Yeah, this is also part of our investigations within our group. We finished a systematic review actually looking at what is Healthspan. That was the question. How do people define Healthspan? Because I can have a definition, you can have a definition, but this doesn't mean that we have consensus and that we have overlap, and how do we define it? So in the systematic review, where we looked at thousands of manuscripts, how the word and the term Healthspan is being used in literature, we found roughly 200 definitions, and there was not much overlap. I think they intended to be overlapping, and most of the times the overlap was Healthspan is being defined as the absence of diseases, age-related diseases, but even the definition for an age-related disease and having a list is questionable. So for me, Healthspan is the absence of a age-related disease, which we can measure, which is defined by the classification of diseases by the World Health Organization. But the literature is not aligned of how we do it. So we have to operationalize that. What is an age-related disease, and how do we measure that also on population level, but also, for example, in randomized control trials. There's also a push to say, okay, should Healthspan also be defined as being subjective? You are feeling good. Is there a role for quality of life? For me personally, I think first we have to measure, and then we can go to the more subjective ones, because we already have quality of life measures, which are quite standardized to measure how somebody is feeling. So, but open for a huge debate at the moment in our field, what Healthspan really is. But for me, it's the absence of a disease, and that also means that many individuals transition from Healthspan to another span at the age of roughly 50, 55, because then the first chronic disease hits.
Can you have one of these chronic diseases and be asymptomatic? So, you could still be feeling healthy, but you have like diabetes or something.
Sure, but I don't want to. If I want to make sure that the listeners do not think that I want to make people sick or
No,
feeling
no,
sick.
no.
Absolutely not.
Yeah.
But very often in our field, we say something and we cannot quantify it. So the
Right.
operationalization is most important. If somebody has diabetes, that actually means that the pancreas failed already a little bit in
Right.
harmonizing the glucose levels, the insulin levels, etc. It's not coping well, which means there is something. And of course, modern medicine really established a system that we don't have to die anymore of diabetes, which is great because we have metformin, we have so many other medications to handle that disease. But still, it's a sign that we have to compensate, for example, with medication. And I think we really have to disentangle the two things. Do you have a disease, which is classified quite well in modern medicine, and then how do you cope with it and how do you feel? If you ask me what is more important, do you have a disease or how do you feel, I would say it's much more important how do you feel also
Mm.
for the remaining lifespan, because I think the psychology and what we do and why we do things in life is much more important. But how to operationalize it is a different thing. I think a step-to-step approach in our new specialty is most important. So let's do it in a way that we know what we are talking about and that we can compare numbers.
Absolutely. Yes. It has to be like scientifically provable. I'd like to have a marker that you can measure. Would you put sarcopenia as one of these diseases?
Absolutely. I
You would.
worked a long time in the sarcopenia field, also helped establishing the ICD code. So ICD stands for International Classification of Diseases, that we can now diagnose if somebody has sarcopenia or not. So there are now standards, there are measurements that every healthcare professional around the world could diagnose sarcopenia. So yes, absolutely. It's an age-related disease. It's now quantifiable, it's measurable, and there is a huge difference compared to other fields, and we have treatments. We already have protein supplementation, resistance exercise training. We know how to reverse sarcopenia, and we now know how to tweak a little bit the satellite cells, which are the stem cells in the muscle, to replicate again, and therewith grow of muscle is there, and a reversal of that disease.
Oh, excellent. So if one of the things you're in your trials is you need to look at endpoints, right? And we did talk a little bit about endpoints, but if we are thinking about trying to reverse aging, although we could talk about whether that actually has any meaning, but what makes a good biomarker for you to judge, okay, that this intervention is moving us in the right direction?
Yeah, the Biomarker of Aging Consortium is working together to not only redefine what biomarkers of aging are, but especially also now validating biomarkers of aging to see if they are meaningful, either in randomized controlled trials, so in research, or if they are even now meaningful in clinical practice. So a biomarker of aging is nothing else than quantifying something which determines how old you really are. So looking at the pace of aging. A very good biomarker of aging is the color of hair. So I am getting grayer and grayer it seems every day. So that's a great biomarker of aging, because it's the likelihood that I'm older compared to 20 years ago. It's quite likely. So it's a biomarker of aging. We often think that biomarkers of aging have to come from blood or from saliva or from other biomaterial, but that's absolutely not the case. The number of wrinkles somebody has is a very good biomarker of aging. And it's quite reproducible that people who have more wrinkles, they are older and having more likelihood to have gray hair. So we are now in an area where we're defining the biomarkers much better, that we know how predictive they are to really determine our biological age, and not only showcasing us how old we really are, But most importantly for a biomarker of aging is also that they are changing, and that change, that the responsiveness to something is meaningful. Coming back to the gray hair, it's very unlikely that I will live longer if I dye my hair and instead of being gray, being whatever, blonde or black haired. So that's not likely that this is a responsive biomarker, which is meaningful, then determining how long I will live, because I'm just dyeing my hair and I'm not interfering with any causality. Because I still have gray hair, I still have wrinkles. That's also the reason why aesthetic medicine is not going to help you to live longer. Maybe you feel better, which is also important, but in the end, the essence of the underlying biology is not being changed. So what we are looking at is really at clinical markers. Think about a glucose level is also a biomarker of aging, or looking at epigenetics, it's also a biomarker of aging, which are aligned not only with the idea that they can indicate how old you are at this moment in time, but they are also responsive to changes. If we do studies and we are giving alpha-ketoglutarate, one of the outcomes, and the main outcome, is epigenetic age. So we hope that this marker is responsive to change. If we are doing interventions to change our metabolism, making us younger in terms of our pancreas function, then glucose or HbA1c or other markers are a good biomarker of age. So biomarkers of age are not just coming out of blood, but they can be clinical. Think about sleep quality, think about heart rate variability. These all are biomarkers of aging.
By the way, which clock are you using?
So there are different clocks. Clocks is nothing else than putting data together and then saying how old are you compared to your peers. So we are modifying the statistics we did previously, and the clocks are now determining not only our chronological age, which is not so important, but especially the risk of mortality and the risk of an age-related disease. So the second and third generation clocks. So we are using lots of biological clocks. Think about clocks being established out of the microbiome or out of the epigenome or even omics data. But most importantly is also using clinical clocks. So we published a paper where we looked at lots of organ systems being clinically measured. Think about blood pressure, pulse wave velocity in the brain. Think about the number of white matter lesions or cognition, for example. So with every marker we can test either in clinical practice or we can do in the lab, we can already build a clock. So there are many clocks, and we are using I would say at least 50 or 60 clocks at this moment in time, because we already know that the clock or the clocks we could measure, that they are ticking differently within one individual. So the clock might show that your heart is aging faster compared to the brain, compared to the lungs, compared to the kidneys. So there's a little bit of a myth around that you have one biological age. That's not the case. The rate of aging and the pace of aging within one individual, within me, is very, very different. So it depends on the clock I am applying and what I measure.
Right. So it's a bit like Mr. Ford sending people around to look in car breaker yards to see which piece of the car was still working well. And it's like, well, I don't need to spend any time on that. So it's the first thing to go wrong that is the problem. And so
yeah, might be the first thing, but it might also be the most important thing. So so there is a sequence of aging we determine. So if one organ system is already declining, it's much more likely that one or the other organ system suffers more or less from that decline. So it's not that the engine has to break before the system is collapsing.
Yes, I saw that on one of your presentations where you were working that kind of graph of dependencies between the different organ systems. Yeah, that was very interesting. So you're working, have you published that, or is it going to be published?
Yeah, all I talk about is published, and the rest will be published just soon. But what we were showcasing is really that there is an interdependency of the aging process of different organ systems. So while speaking now, I not only need my brain to say what do I say and does it make sense, but I also need, for example, my muscles. I'm speaking at this moment in time. I also need some oxygen, hopefully. Through my lungs to my veins and to my arteria to actually give some oxygen to my brain to hopefully to say something which makes sense. So there is an interaction, and very often we are just looking at one cell, at one organ system separately, but we forget that there is an interdependency. Because if I would stop breathing at this moment in time, we could stop the interview because it would not make sense. So this happens not only acutely, but especially chronically. So if my lung function, for example, would go down during the aging process in the next coming 10 years, that influences how my heart is functioning or how my brain is functioning. And so these little tiny differences in sequences really determines how good or not good somebody ages and how fast somebody ages.
Have you gathered enough data to be able to determine what is common, what is like the commonest part to age first?
No, and I don't think that really exists. If I'm honest, and if looking at the data, I think there are clusters of individuals who first age in terms of their heart or cardiovascular system, their vessels. Some are aging faster in the lung and the pulmonary system. So what we are looking at and trying to understand at the moment is, where does it start? It starts everywhere. I think it's more about the pace, I must say, because every of our organ system is aging. I haven't really found cells escaping it. So it's more, where is it faster, and how does the rest of the organs and the other cells react? How resilient are they to the change of their sort of neighbors?
Right. Okay. So one last question. You mentioned a cognitive clock. So there's, like, you do cognitive tests and how your results are, then it gives you a cognitive age. Yeah.
Yeah, I think cognition is very important. We always, in clinical practice, we say you should be able to walk and talk and have friends. So if you're looking at all these three factors, cognition is very important. Like, even if we are walking, it's a cognitive process. Talking means I need my brain, I need capacity and the willingness to talk. And then making friends, I think, really brings the social aspect into it. So cognition is very often underrated at the moment, because neuroscience, health longevity medicine is really looking at focusing on the biology of aging. And we heavily invest into the cognitive part, but also the psychology. What is the willingness to do things? Why do you want to change? How is the environment look like? How do you adapt cognitively, but also psychologically to changes, not only biologically, but also in terms of the environment? So cognitive tests are a huge part of our assessments in all our either patients or clients in clinical practice or participants in our trials.
Yes, that seems like so important. I don't suppose there's any openware or open cognitive tests that people can do.
There are a couple. Most importantly is, I would say, do it right and do a very good cognitive assessment. So there are lots of apps looking at executive functions. How good are you, for example, on an app on a phone to react? There are subtraction, so mathematical tests. But if people are really interested, even ask your GP to do a test or even a screening test. And very positively is that we now have the idea, and the first first results that we can change how we age cognitively and we can train it. It's a little bit like preventing sarcopenia, which is low muscle mass and muscle strength. We now can show, we do active trials with it, that we can improve cognitive function while going a little bit to the gym with our brain. So there are already gyms who are heavily focusing on that, to not only train the body, so giving you better endurance, better balance, and better strength, but also giving you better cognitive function, for example, to double task.
Yes, it'd be great to go down into that, but it would be a rabbit hole. So interventions. So one of the things you're looking at is intervention. We kind of talked about some of those before, AKG and NMN. But if we kind of more widely look at that, so how do you think about interventions that might help? And what are you kind of looking at, either Singapore or worldwide?
So we have 4 different types of interventions after having done a sort of diagnostics, knowing what that individual needs and how biologically old somebody is. So the first one, very often forgotten, are environmental interventions. The environment we are living in, the noise level during our sleeping time, the temperature, who we are surrounded with is not only a determinant of how long somebody will live or what the healthspan is, but it's also a great opportunity to change that, and therewith change biology, and therewith changing the healthspan. So environment, the exposome, it's also now called, is very important. Then we have lifestyle changes. Very often we think a little bit negative about lifestyle changes, but they are hugely potent to change our trajectory on how we age. And especially, and this is most important, if we are individualizing it to the needs of a certain individual. So it's not just following the WHO guidelines. I think everybody should follow the WHO guidelines and stick to it. But how do we then individualize it to really bring it into precision, that you know, I know, somebody knows what to do to even then extend that healthspan and lifestyle, additionally to all the recommendations we have. What is the optimal training program for your physical health, for example, in terms of endurance, balance, and strength, which was just one example. How much endurance should I do compared to strength training? What is my optimal strength level at certain times in my life? So that's what is hugely being studied at this moment in time. What should I eat based on, for example, my microbiome? Healthy eating, that's fine. Mediterranean diet, absolutely good. But who should do intermittent fasting, time-restricted eating, caloric restriction, all these things? So we really have to learn how to handle that. And that also, in my view, falls under lifestyle interventions. Then the third one are supplements. We already touched on that. Yes, we are studying that hugely at the moment at the National University of Singapore, and not only AKG and NMN, but we are very interested also in others like urolithin A, spermidin, fisetin, and other supplements we have, which are already available over the counter, and we now really have to see, does it work? Which combinations do work? What's the dosage which works? So really fine-tuning the body while adding supplements, and very often these are natural ingredients. Think about NMN, it's already present in cucumber and lots of other food, but giving different dosages. And then the fourth one is drugs, and these can be split up and repurposed, and novel drugs to antagonize the aging process. So repurposed drugs, think about even now metformin, ACE inhibitor, GLP-1 receptor antagonist, and many, many more. And then the new drugs, which is, I think, very exciting, but it's more the longer term before being available on the market.
So I think Singapore is kind of ahead in the way that they think about aging and are trialing. And I mean, I think that's one of the reasons you're there and the way they're working. Are there other centers that you are working with? Because you did start the Center for Healthy Aging, or what was it called? The Healthy Longevity Medicine Society. So are there other areas that are working with you, or is kind of Singapore leading on its own?
No, this is a worldwide approach, and we formed a community of maybe not always like-minded researchers, but at least the researchers who have the same aim, and that's improving and optimizing Healthspan, and that's most important because we need that debate in our field, and we need different approaches to optimize health and Healthspan of aging individuals. There are many more centers around the globe, in Europe and the US. We are actively working with, we are exchanging ideas. We are even now planning to do trials together, not only in consortium within continents, for example. There is already a consortium in the US working together, but now really aligning the global view and doing trials worldwide. So no, we are not alone, which is great. And yes, we are forming consortia. Consortia are very important for decision making and for example, agreeing on terminology like Healthspan or what is a biomarker of aging. And I think most importantly is at the moment the Biomarkers of Aging Consortium, which is bringing researchers together globally out of all continents to really drive the field how we can measure the biological age of individuals. And then you already touched on the Healthy Longevity Medicine Society. I'm the current president of that society, where we are bringing together healthcare professionals to really find out what the scope is of healthcare professionals around the globe to practice what we already know from research in clinical practice. So how to optimize health of aging individuals.
I see that in your presentations, you talk about evidence-based, which absolutely makes sense. Now, the thing is, like the FDA would say that they're evidence-based, right? But they have very strict rules about the kind of evidence and how it works, which makes it very expensive to get over that hurdle. So what kind of evidence are you looking at? How are you going to judge that it is sufficient to make a recommendation?
Yeah, so it depends on who you make the recommendation towards to. So I am setting up with all my colleagues globally the framework to bring healthy longevity medicine, or we now call it geromedicine, into clinical practice, which means if you are practicing something as a physician, you need a scope. You need to know what to do. Conventional medicine, which is thriving since decades now, is based on evidence. So evidence-based, we have Cochrane guidelines. We are utilizing the research to then bring the best of the research into clinical practice, which is most of the times most efficient. So which means individuals have a positive outcome. So it needs to be meaningful for individuals. And if you really want to implement something, it also has to be cost effective. It has to be effective in a way that it's worthwhile, the investment, financial investment for society. So it needs to be clinically effective and at certain times also financially effective, so cost effective. We are building the scope at this moment in time, what should be implemented into clinical care and what not. And you ask me, what is evidence? So we have frameworks, which we are borrowing from other medical specialities. So for me personally, it's very important that whatever we do has been tested in humans. Yeah. And yeah, you say yes, but very often there is lots on the market already, which is over the counter, which has not even been tested very often in humans. Secondly, it should not only be tested in humans, but it should also be effective. and you should know what possible side effects are. So very often that's also a missing link. If you're looking at the past, small molecules being tested in mice, showcasing a 20 or 30, sometimes even 50% increase in lifespan, is then directly being taken by individuals, by humans. And I think that's far too stretched. I think we need much more evidence. So it should be tested in a very good study design. At the moment, it's randomized controlled trials where you know what the placebo effect is and you have the outcomes. If you're looking at other specialties, think about endocrinology, oncology. These are big studies. Phase 3, where we have most of the times hundreds and thousands of individuals, and you're showcasing in whom it works and in whom it doesn't. And that leads to guidelines for clinicians, but it also leads to guidelines for consumers. I don't think that we really have to disentangle what clinicians should do, also what consumers should do, because the wellness market is growing, and we need much more guidance of that growing consumer market towards, I think, a knowledge base that they can make a right choice. So who needs what? It doesn't mean that you can buy it on the shelf and in whatever website that it's good for you. I think very important is to make the matchmaking between what does that body at this moment in time need, and how do we actually do it, with what interventions, for how long, and how do we measure that it's actually working and measuring the outcome.
Yes. So a question in there. So where does the funding come from? I mean, if you're looking at a big clinical trial, I mean, that is non-trivially expensive.
Yeah, I would turn it around. Very often I get a little bit the criticism, like, why would you test it? Like, if people want to take it, just let them. I want to know if we can manipulate the body positively. So manipulation is now very positive towards a healthier life and towards a healthier functioning body. So, and I do not separate really health longevity medicine practices from conventional medicine. For me, in the next coming years, in every country, healthy longevity medicine should be implemented in normal care. Why should you wait until a disease occurs and we are diagnosing, and why shouldn't we actually prevent that? And there is actually a financial business case. If we could prevent age-related diseases and we could intervene much earlier, that doesn't only mean that people might feel better, but they might also be more productive. They might be able to be much longer in the workforce. Even because of the severity of the changes already might be lesser. There is a case that the spending upfront might be much better compared to diagnosing a disease much later, and there was having lots of costs of age-related diseases later in life. So I think from a funding perspective, it should be funded by regular mechanisms. We have to compete with other specialties for funding, for research funding, and that's happening at this moment in time. It's not that we are relying fully anymore on philanthropy, for example, or donations of individuals. I think if we want to take us seriously, and I take healthy longevity medicine very seriously, we have to compete and we have to improve the quality of what we do, and then doing the randomized controlled trials. And that's being seen also now by the bigger pharma who is doing the randomized controlled trials in phase 3 of up to phase 3, that there might also be a business case for them, because 100% of the population is aging, so might be a need for certain drugs and for certain interventions. So in summary, I think let's just bring a huge amount of quality studies into the field, and let's compete with the money there is. And I think prevention is up front on all the agendas of not only agencies who give research money out, but also of many governments.
Interesting, yes. And I think there is I mean, a point you made, it's like just let people take it. I think that there is a great desire for people to know more, to try to know what to trust, what information to trust. So what can I take and how? So we definitely want that information, but it is, yeah, it's kind of scarce at the moment. And so
absolutely, and I think the regulatory that's a regulation problem, and what source to trust. You might have heard of our study where we tested supplements which consumers can take, and we showcased that. Look, 1/3 of the supplements might be of good quality, but 2/3 not. And this is not new in the field, because we already have the evidence that for other supplements like a vitamin D or melatonin or other or protein even supplements, that there is a lack of high quality products, or that the majority is not delivering the high quality. So, and consumers are suffering from it, and that's very important. So we really need a source, and therewith maybe also better regulation of what is quality and what not, and what should be taken or not, and having certifications of good quality products. And that's what we are working on.
Yes, excellent. So one question, you talked about taking the interventions into the clinic. Now, my understanding of the way doctors work, which could be completely wrong, right, is that they have like a manual, and they need to prescribe according to that. They don't have much flexibility. So, like for a particular for a particular indication, they would need to prescribe a certain drug, like which would need to be FDA approved, like in the US, for example. But would you be able to put the aging interventions in the same way that like an ordinary doctor would be able to prescribe them to a patient, or would they, or it would need to be a specialized clinic?
In the end, but this is the future of hopefully within 10 years, I think every GP should practice geromedicine or health longevity medicine. And why do I say that? Because I haven't found anybody who's escaping the aging process at this moment in time. So we need a huge basis. Where should we start is the question. At the moment, within the Health Longevity Medicine Society, we have a variety of specialisms. We have GPs, yes. We have many internal medicine specialists, but we also have surgeons. We have aesthetic medicine doctors. We have a huge variety. So in my view, it should really start within internal medicine. Internal medicine specialists understand the physiology. They have a huge understanding already about the drugs we might want to repurpose in the future, also in clinical practice. I would just give you 2 examples. Everybody is talking about metformin and the TAME study. Yes, I know how to prescribe that. I know what kind of side effects we have. So the question is, can I prescribe it to a different population once we have the result? The same for rapamycin. Yes, I worked on transplant departments within the kidney departments, nephrology. Yes, we have understanding. So I think it originates within internal medicine, at least for me. And I will give you an example. If you're looking back 20 years ago, type 1 diabetics or COPD patients, they were treated by endocrinologists first, or by pulmonologists, so really specialists for the lungs and for the endocrine system. Now, in many countries, it's being handled by general practitioners in the first line of in primary care. So I think always, if you start something new, there's a transition of who is doing the work, and based on how special it is, what you do, how many guidelines there are, how much also involvement there is of innovation. I think it should really start in academic clinics, and that's what we do with many academic clinics who are now doing the randomized controlled trials. And once we have the evidence, it can go to non-specialized clinics, and it can go to, I think, the primary force of family medicine.
Yes, scalability is going to be the big thing. Um, so as we get towards the end, what would you what do you hope for in 5 years? I mean, if you look forward to aging, how could we improve aging in the next 5 years?
Well, that's very easy. So we have a couple of countries where health longevity medicine is being recognized as a specialty, that there's a scope of working, that we know what we do and what we don't do. So that's more from the clinical side, but from a scientific side, I think we have so many trials at the moment going not only in my group, but worldwide, that we in 5 years, we not only know how to diagnose very accurately, very precise the biological understanding of aging, so the biomarkers of aging, but we also have the interventions and we have a matchmaking that we can increase the health span of individuals by, I would say, at least three years.
Right. Do you see a role for AI, like you just kind of put all your biomarkers into this AI machine and it spits out at a suggestion?
Yeah, sure. We are doing, many groups are using machine learning AI to understand data. We have so many data points.
Mm-hmm.
I analyze myself very often. I have so many data points. I think no brain, even if it's a trained brain, exercising a lot, cannot handle all that information. And we are now living in an area while I think nobody is escaping ChatGPT anymore. And all these algorithms are already included in normal general care. And I think what we are trying to achieve within health longevity medicine, but also in research now, how can we apply it? What kind of data are really needed? What is essential? And there was optimize not only the diagnostic process, but especially also the intervention process of individuals by these new technologies we have in hand. Very importantly, maybe to mention it, AI and machine learning will only help if you have good data. So good data are important. We need accurate parameters to then give also an accurate answer what to do and maybe what not.
Excellent. Yes. Okay. Is there anything else that I have not kind of asked you about, or is it something else you would like to share?
There is one more point being very often forgotten, because consumers are very often looking for solutions. So jumping to the internet and looking at lots of blogs, following biohackers, that might not be the solution in my view. The really jumping into interventions, the first thing I think step everybody should do is understanding yourself, measuring what your starting point is, and then deciding what kind of intervention would fit or not, and really seeking advice of healthcare professionals or researchers or coming into the community, because it's very likely that we don't have a pill, or will never have a pill which fits everybody. But knowing what your genome is, how your microbiome is acting at this moment in time, but even looking what is the strength status, how good are your muscles at this moment in time, what is the endurance, what is the cognitive state. I think that's the starting point for anything leading towards interventions, where to invest in, when.
Right. So one thing on that, if I wanted to, I was watching this, I wanted to take an inventory of myself. What are the top 5 things I should look at, or however many you think is appropriate to get the baseline? I mean, I'm sure there's all sorts of detail I could go into, but I want to have a measure of where I am.
The first step is, I think, getting a wearable device, measuring either even the step count, that should be available for everyone, and it's quite cheap because a pedometer is not more than $5. So measuring, first of all, the physical behavior is good. If people want to invest more, really giving smart devices like trackers, like a smart watch, a smart ring, where you can really see not only what your heart rate variability is, but also the sleep quality, how long somebody sleeps, what is actually interacting with sleep, how much REM and deep sleep does somebody have. Having now these devices and being able to track bodily functions is of utmost importance. And of course, this is just what we do and how our body reacts, and then understanding why is it reacting like this. So as mentioned, cognition is very important. Even muscle strength is so important to know, because you can train it, it's modifiable. And of course, there are a lot of consumer products already out there to measure the genome or the epigenome, etc. This is, I think, a step forward after having really measured the basic principles. What do you do during a day? How do you sleep? And then also evaluating with yourself, how do you feel? It's very important.
Right. Yes. Yeah. I mean, I think the thing is, yes, there's like supplements and whatever, but the lifestyle things are known. And so you don't really need to do that much. Well, you can measure to see how good or bad your lifestyles are, but like improving them is not that difficult generally. You know what and there's no downsides to exercise and
Sure. But how much to exercise? Yeah. So when do you get return from your investment back? So how much zone 2 or 4 or whatever exercise should you do? Should you actually focusing on endurance training, or should you focus more on strength? Should you focus more on balance? So as I said, I think everybody should do and follow the WHO guidelines, and having a good weight and not being overweight. We all know that. And restricting your salt intake, that's all known. But then it's about how do we fine-tune the body to maximize the chance that we are living healthier for longer. And that's really the fine-tuning. Yes, everybody who has a bad lifestyle can gain, I would say, at least 8 to 10 years of a longer life while changing that. We know that. But how to optimize it based on your physiology, based on your genome, based on your mood, what you would like to do, I think that's of utmost importance. How to not just be normal, but how to be optimal.
Yes. That is the goal, optimal health span. Okay, Dr. Maier, thank you so much for joining us today. Where can people go to follow your work, follow the trials you're doing?
Yeah, there are 2 important websites, and that's the longevityacademy.sg, where we now also translate our research findings into readable pieces, which are digestible. So longevityacademy.sg. And I think from a broader view, the Healthy Longevity Medicine Society will also release these kind of informations, and that is hlms.co.
Okay, excellent. We will link to them in the description.
And follow me on LinkedIn. Lots of information also there, and don't hesitate to reach out.
Okay, excellent. Thank you so much, Dr. Maier.
Thank you.